For decades, Voyager 1 has been traveling farther from Earth than any spacecraft humanity has ever built. But even after nearly half a century in deep space, this remarkable machine still manages to surprise the scientists watching it. In 2023, engineers noticed something unusual. Voyager 1 was still communicating with Earth, and its signal remained stable, but the information coming from one of its onboard systems suddenly appeared corrupted and meaningless. The system involved was the spacecraft's attitude control system. Its job is extremely important because Voyager has to maintain the correct orientation so that its antenna can continue pointing toward Earth. At first, the strange telemetry created a major mystery. The spacecraft itself appeared to be operating normally. Its scientific instruments were still collecting information, and there was no obvious emergency warning. Eventually, engineers discovered that Voyager had been sending its telemetry through a computer that was no longer supposed to handle that information. Rather than being a catastrophic failure, the problem appeared to be connected to the way the spacecraft was routing its data. Engineers carefully developed a new command sequence that redirected the information through a functioning computer. The solution sounds simple, but communicating with Voyager is anything but simple. The spacecraft is billions of kilometers away, meaning every instruction must travel across an enormous distance before engineers can determine whether it worked. And Voyager is not equipped with anything resembling the powerful computers we use today. Its memory is incredibly limited by modern standards. Yet this tiny amount of computing power has helped the spacecraft survive for decades in an environment filled with radiation, extreme cold, and almost complete isolation. That endurance is one of the reasons the Voyager missions remain so important. Long before Voyager entered interstellar space, the spacecraft transformed our understanding of the outer solar system. When Voyager reached Jupiter, scientists discovered a world far more dynamic than they had imagined. Massive storms dominated its atmosphere, while powerful auroras illuminated its polar regions. But one of the biggest surprises came from Jupiter's moon Io. Voyager revealed active volcanoes erupting across the moon's surface. It was a discovery that completely changed the way scientists thought about volcanic activity beyond Earth. Saturn brought another revelation. Its rings were not simply a few smooth bands surrounding the planet. Close observations revealed an intricate system containing countless structures and narrow ringlets. Then Voyager 2 continued outward. It eventually became the first spacecraft to make close encounters with Uranus and Neptune, giving humanity its first detailed views of these distant ice giants. At Neptune, Voyager discovered an unexpectedly active world, while its observations of Triton revealed signs of unusual activity on the frozen moon. But perhaps the most emotional moment in Voyager's story happened when the spacecraft looked back toward home. In 1990, Voyager 1 turned its camera toward Earth from billions of kilometers away. The resulting photograph showed our planet as an extremely tiny point of light against the darkness of space. That image became known as the pale blue dot. It offered something that went beyond scientific measurements. It showed just how small and fragile our home appears when viewed from the enormous scale of the cosmos. And Voyager was not finished. After completing its planetary missions, both spacecraft continued traveling outward. Eventually, Voyager 1 crossed the heliosphere and entered interstellar space, becoming the first human-made spacecraft to reach that environment. Voyager 2 followed years later. Beyond the protective region dominated by the solar wind, the spacecraft began measuring conditions in the space between stars. For scientists, this created an extraordinary opportunity. Instead of studying interstellar space only through distant observations, humanity now had instruments operating directly within it. And that is where Voyager's story becomes even more remarkable. The spacecraft that began its journey in the 1970s was still sending scientific information from an environment no human spacecraft had previously explored. Nearly 5 decades after launch, these aging machines continued doing something incredibly simple yet profound. They kept moving forward. Voyager's journey did not end when the spacecraft crossed beyond the Sun's protective bubble. In fact, entering interstellar space opened a completely new chapter. The boundary surrounding our solar system is not a perfectly fixed wall. It changes as solar activity interacts with the surrounding interstellar environment. Voyager's measurements have helped scientists study this complicated transition and understand how our solar system interacts with the space between stars. One particularly important discovery involved energetic particles. Beyond the heliosphere, Voyager detected changes in cosmic ray activity, providing scientists with valuable information about the radiation environment outside the Sun's influence. It was a reminder that interstellar space is not an empty, completely silent void. There is energy, radiation, magnetic activity, and an enormous amount of information waiting to be measured. Then came another fascinating observation. Voyager 1 detected a very faint, persistent signal associated with the surrounding interstellar plasma. It was not a mysterious voice or an artificial transmission. Instead, it represented the natural activity of the environment through which the spacecraft was traveling. For scientists, even a subtle signal like this can reveal information about the density and behavior of material between the stars. But keeping Voyager alive has become increasingly difficult. The spacecraft are powered by radioisotope generators, and their available power gradually decreases with time. Every year, there is less energy available to operate the spacecraft. That means engineers have had to make difficult decisions about which systems can remain active. Non-essential equipment has been switched off, and some systems have had to operate under conditions they were never originally expected to survive for so long. Yet Voyager continues. That alone is extraordinary. These spacecraft were designed for a mission that was never expected to last this long. Instead, they became some of humanity's longest-running scientific explorers. Their survival has also challenged scientists' expectations about how spacecraft systems behave after decades in deep space. Voyager's measurements have continued to provide clues about the heliosphere and the environment beyond it. Comparisons with missions such as IBEX have helped researchers build a more complete picture of the boundaries surrounding our solar system. But the farther Voyager travels, the more difficult communication becomes. The radio signal is incredibly weak by the time it reaches Earth. A command sent from Earth can take many hours to reach the spacecraft, and the return signal takes many more hours to come back. Engineers therefore cannot operate Voyager the way we operate a nearby spacecraft. Every command must be carefully planned. Every response must be analyzed. And every successful transmission is a small victory. There have also been dramatic claims about unusual objects supposedly detected by Voyager. Some stories have suggested that hundreds of massive unidentified objects were discovered in deep space. Such claims have generated enormous public interest, but extraordinary interpretations require extraordinary evidence. What we can say with confidence is that Voyager has provided humanity with an unprecedented view of the distant environment beyond the heliosphere. And its real discoveries are already extraordinary enough. Think about what these spacecraft represent. They were launched in the 1970s with technology that is primitive compared with modern computers. Their processors are incredibly limited. Their power supply is slowly fading. Their signals are becoming weaker. And yet, they continue sending information across billions of kilometers. The Voyagers have traveled farther than any other human-made machines. They have visited worlds that no other spacecraft has explored in the same way. They transformed our understanding of Jupiter, Saturn, Uranus, Neptune, and the outer solar system. They gave humanity one of the most famous photographs of Earth ever taken. And now, they are carrying humanity's presence farther into the space between the stars. Their journey is a reminder that exploration does not always require knowing exactly what will be found. Sometimes, the greatest discoveries come from simply continuing to look. Voyager 1 and Voyager 2 began as planetary exploration missions. Today, they are something much bigger. They are distant scientific laboratories, technological time capsules, and messengers from Earth traveling into the unknown. Long after their instruments finally go silent, the paths they traveled will remain part of human history. Because Voyager was never just about reaching another planet. It was about discovering how far humanity could send a message into the darkness. And even after nearly 50 years, that journey is still continuing.